Hi everyone and welcome. Today I would like to talk to you about firewalls. We are going to be talking about how restrictions are set up using some examples of when you might want to do a firewall such as SSH limitations and how we can add and subtract firewall rules as well as managing our IP table and what other options are out there other than IP tables. Firewalls in general are considered a first line of defense. They are one of the first sets of protection that we will see on our network and or computers. The basic purpose of a firewall is examining the packets that are coming in and out of the network. We can decide if the packet is going to be allowed into the network, or if we would like to deny the packet access, or if we would like to redirect the packet somewhere else. We can look at the basics of the packet. Where did it come from? Where is it going to? We can also do deep packet analysis and start looking at the data within the packets. We can check what port it's using or the application that's coming through. One thing to note, the deeper you are looking in the packet, the longer it's going to take for your firewall to decide what to do with the packet, and therefore you can end up creating some bottlenecks. At the basic level, a firewall can deny all or allow all. Now, what I mean by that is when we have a firewall, we have a set of rules that we're going to want to follow. Now, if a packet doesn't fit one of those rules, we have a packet that comes in and it doesn't match any of our rules, what's going to happen is it's going to start at the top and go down the list until it finds a rule that fits. Or if it gets to the end of the list and no rules fit, then it has to have a deny or allow condition. If we have deny all, it's safer, but as admins, we end up having more work that we have to do because if it was actually legitimate, we have to then go add in a rule. We could have packets that are allow all, the more permissive option. So if it doesn't fit any rules, we automatically allow it in. Now, this is less work for an admin, but it is also by definition less secure. Now, one of the things about deny all is as admins putting together our firewalls, that means we have to come up with all of these example use cases. So we have to think of all of the potential things that could happen and decide what we want to do in each of those cases. So that can sometimes be really difficult, but if we have something that say like maybe we are a government entity or we are a large company that gets attacked a lot, then we might want to have deny all because it is safer and we would rather put in the work for a safer network. However, if we have maybe a smaller company or it's not as dangerous of a area of commerce, so what I mean by that is, let's say you're working R&D at creating some kind of weaponry. That is obviously going to need way more protections than somebody who's, say, creating teddy bears to sell. It is probably more unlikely that somebody is going to attack a teddy bear seller, you know? So we have to decide which option we want to take. Do we want to deny all and put in more work? Do we want to allow all, put in less work, but know that it is going to be a little bit less safe? The easiest or quickest way to filter data is looking at the IP address or the MAC address. Where is it coming from? Where is it going to? If we start looking at the data that's actually contained within the packet, that's going to be our slowest option. We can do some things like filtering packets by port. So for example, if we are running a DNS server, we know that our DNS server doesn't need the ports open to be able to send emails. We probably don't want our DNS server sending emails. So we can block email ports, typical email ports. We could look at things like ping. Being able to ping a server is really great for testing connections. But if you allow ping, then you are allowing the ICMP protocol, which means you allow Nmap style attacks. So you have to think about the trade-offs. There isn't a everybody should do this because this is the perfect thing for everybody. An example of this is for one of the servers that I admin, I have to be mindful of who's actually using the server. So I have to think about who is using the server, what are the use cases that they are going to have, and how does this affect the security. Now, because I am a teacher, most of the people using the server are going to be students. By definition, students make mistakes. We all make mistakes, but as we are learning to do things, we are more likely to make more mistakes. So I have to have more permissive access in a lot of cases to this server because I have to think of the use cases of people who have maybe never SSH'd into a server before and how that's going to affect the security. That also conversely means that I have to pay attention to use cases in terms of what they shouldn't be doing. So it is more important to lock down some of the access in the server because there are so many people on the server that, and I don't mean this in a bad way, but they don't really know what they're doing. So they can do some accidental things that I might not even have thought of. So I might want to do some extra protections there. Same thing happens with firewalls and companies. You really have to think of the use cases, who's going to be accessing what, why, what makes sense. Now, when we talk about firewalls, we can sort of split firewalls into two general categories, stateful and stateless. Stateless firewalls are going to be static information. So it's going to be looking at, say, source and destination. It does packet filtering, matching these conditions, pre-approved actions. It can also be known as an access control list. You may remember that from your security. It basically focuses on packet filtering. It's also considered faster because all we're looking at is where is this coming from? Okay, great, here you go, come in. Stateful firewalls are based on full context. That means once the traffic is approved, it's added to the state table and can get more or less access to the protected network. If it isn't approved, it can get blocked. And the stateful firewalls can also be better at figuring out if it's unauthorized access or forged information because it's taking a little bit of a deeper and more active look. Now, technically, Windows Firewall is also considered stateful, but we don't care because we're talking about Linux right now. Now, let's take an example of where we might want to use firewalls. So, a distributed denial of service attack or a DDoS attack. A DDoS attack is where somebody is going to come in and try to overwhelm our systems with requests of some variety. One of the things that we can do with our firewall is we can filter some of the requests that are coming in. So if we know that we have requests that are, say, absolutely no way that this is a legitimate request, we can filter some of that out. One of the things that makes DDoS style attacks really difficult is because it is sometimes really hard to tell if it is legitimate traffic or not. So if we think about like something going viral, right? And so if we have something on the internet that's gone viral and it's pointing to a slightly obscure website. Now, in normal cases, maybe that website gets 100 hits a day. In this case, they're getting 100,000 hits a day. Now, that's actually legitimate traffic. It went viral for whatever reason. People are really interested in this pretend project. And so that's actually legitimately people want access. So the difference between that and say, somebody came in and decided to be a meanie and do a brigade, can be difficult to be able to tell, especially in that moment. That's why there's some like third parties that actually make quite a bit of money being able to help prevent DDoS style attacks. So one of the things that we can do with our firewalls for this is we can do things like filter IP addresses or IP address ranges. So if we know that, let's say, our server is always getting hit by a specific set of addresses or a range of addresses, we could block them. I'll use the example of the CIS server again. So the server for the tech department, some of the things that we have to do to protect it, because there are students logging into it, is we have to think about who is logging in. Now, because we are a community college and the people that are taking the classes are most likely local to the location of the community college, we could narrow it down that much, but it's very unlikely that we're going to have, say, a lot of people trying to access the server internationally. So the likelihood that I'm going to have somebody who's in China trying to access the server for homework legitimately isn't high, because that server is really only getting used for homework during a semester. And a lot of the classes are in person, and China is frankly not a reasonable commute from anywhere in the United States. So we can actually filter out those addresses from, say, China, South America, and by filtering those out, that'll block a lot of the sort of junk traffic coming in, because we know that that can't be legitimate access. Now, as a note, IP address filtering like this for, DDoS attacks or anything else, this is taking out script kiddies. This is not necessarily taking out the really good hackers or advanced persistent threats or anything like that. This is just one of the many things we do, because remember, defense in depth. So people can get around this. It's just one option. Now, normally I would have an activity here. However, since we're online, that's not going to happen. So if you'd like to pause me and start thinking about some things that you might like to do for a DDoS attack on your server, start thinking about that, make a list of priorities, start speccing it out like if you were going to write a script. Feel free to pause me and then come back. Welcome back. So now we can look at firewall implementation specifically in Linux. Now in Linux, there's actually several options for how firewalls are put in place. Now, iptables are the most common option, and most systems do actually have iptables somewhere in the bowels of the system. However, very commonly you might see nftables, firewalld, and UFW, the uncomplicated firewall from Ubuntu. Those are usually some kind of wrapper. Sometimes they'll be scripts, sometimes they will be applications, sometimes they'll be GUIs, but there are other options that you might see. One thing that I would recommend is whatever is on the system and recommended from the documentation on the system, use that to start with. So like if you are running an Ubuntu server, start with using uncomplicated firewall, and then only try adding in or changing iptables at the command prompt with the iptables commands. If you really have to, try going with what the suggested method is first. iptables do not survive reboot. We do have ways we can preserve them, but some of the different options for how we do firewalls on Linux, some survive reboot, some don't. Some are actually scripts that rewrite the firewall every time. Some are changes that we make to the actual firewall. Super depends just what flavor of Linux we're talking about. Now, one thing that I would like to recommend is there is a very lovely person that does, comics on Twitter, and she shares them all publicly. They share them all publicly. And the descriptions and visualizations that they use, I think, are great. So if you would like a breakdown of a different way of looking at IP tables, I will strongly recommend Julia Evans at Bork, I hope I pronounced that correctly, on Twitter. She also has some books and stuff that I have in the office if you'd like to read them at any point. Now again, normally I would have an activity here, so I guess pause me for a minute and go find your IP tables, list the rules, try blocking an address, try deleting a rule to block the address, and try seeing if you can find the IPv6 rules. Firewall rules. All of the rules are done in a chain format. The order matters. So the rules will get looked at. If the rule is used to do something, that's just where we stop in the chain. The allow all or deny all is always going to be the end of the chain. We can choose to either accept the packet, bring it into the network. We can also drop or reject. Drop gets rid of it, no notification. Reject will send back an error. And you can choose which one's the best in your cases. You'll also see sometimes that people will create scripts for some base rules or to modify rules in some common scenarios or emergency scenarios. Let's say, for example, in the case of hacking, maybe we want to have a lockdown. So we are going to have a, sort of emergency script that we would be able to run so that we have everything all planned out, everybody's agreed to it, and we have everything all set and ready to go. We can also do things like perfect our IP tables in IPv4, and then we can create a script to do the IPv6 set. That's another really common thing you'll sometimes see. Now, firewall chain rules. We have separate chains, and you can see from the image that this is going to be deciding where the packet is as it's coming into the network. So as the packets are arriving, it's considered pre-routing. As the packets are leaving, it's considered post-routing. All of these are going to have different tables, which I'll talk about in a minute. All of these separate chains are going to be dealing with the packets in different places as they go around the network. So let's take an example. Let's say we would like to work with IP tables and we just want to add a basic rule. We want to drop something. So in this case, we want to drop by IP address. So you can list your IP tables rules and then add in a drop rule to drop by IP address and then get rid of the drop rule. So you can kind of see how these different rules are added to our different chains. Normally I would have an activity here. So I guess I would say try out writing a script to show your IP tables rules, show your IPv6 tables rules, add in some headings and some titles so that it's a little more obvious what everything is. And also try writing a script to shut down everybody on the system except you, a common script that you might see in case of a potential or suspected hack. Okay, a little bit more in depth for the tables. So each of the places that the packet can come into our network might have different sets of tables. The main table that you're going to be working with is the filter table. However, it is worth knowing that there are other tables out there. It's just that we mostly end up working with the filter table. Now, another thing that we can do with firewalls is we can actually create something called a DMZ or a demilitarized zone. So I sort of affectionately call the problem children web, email, VoIP, and FTP. And you're probably going to want to place them in a DMZ. The reason that you want to do this is because these are going to be some of the more problematic applications. They have to have public availability. If you have a website, you probably want people to go to your website. Therefore, you have to open it to the outside world. As soon as we open things to the outside world, it all just goes downhill. So we want to have some extra protections. Email, I'm sure we all have seen all of the spam messages, notifications that somebody fell for a phishing attack, and all of the viruses that come through an email. But basically anything where we are opening ourselves up to the outside world, we want to have a separate set of protections for, and the DMZ can be great for this. We can have all of the packets that are going to these particular problem children and sort of shove them off to the side before they get into our network, so that we can have a way of being able to protect them from our network a little bit. Another thing you'll see really commonly is actually dual firewalls. So we can have a firewall at the front end, which would allow the DMZ traffic. Then we can have a second firewall at the back end that allows traffic to the DMZ from internally. So we can actually have, again, this layered approach, defense in depth. So we don't have to just have one firewall and hope it holds. We can have multiple firewalls. If you kind of think of them like our network is a castle. The firewalls are the large walls that people build around a castle. If you have more walls in different places, then you are able to protect different areas of your land. So if you have a wall around your sort of internal keep, then you're going to be protecting your inner network. Whereas if you have a wall around maybe where the goats and sheep are grazing, then it's a larger wall. It's harder to sort of watch over, and sort of by definition needs to have a little bit more space and permissiveness, because goats get in everything, just like human users. And so as soon as you're opening places up, to the goats, having extra protection is nice. Goats grazing on your grass, adorable. Goats grazing on your, bedroom sheets, less adorable. So having multiple firewalls is actually really common. Another thing that you'll sometimes see is people will use multiple firewalls from different vendors. So the theory is, if one vendor has a vulnerability and you're using two different vendors, you are unlikely to have the same vulnerability within both vendors. So it's kind of like, your wall has holes and you just want to make sure that the wall holes don't line up, because then people can shoot arrows through. So that was the ideas on firewalls, what they are, how they're put together, how Linux does firewalls, some examples and activities so that you can start playing with firewalls, and talking a little bit about how we can set up rules, tables, and what the chains are. I hope everybody is doing well, and I hope you all have a lovely rest of your day.